All right, let's talk about mass moment of inertia. All right, mass moment of inertia, I'm going to represent with IZ is equal to the integral of the mass r squared dm. Okay, and for those of you that like pictures like me, here is my axis Z with my big blobby mass here, M. Okay, and we're going to have a volume cube here that is dm, that is acting at a perpendicular radius r. Okay, so hopefully this looks very familiar to second moment of area, right, which is inertia. So instead of doing area and a centroid, we're going to be doing mass and its mass center. Mass moment of inertia has a supplemental worksheet posted to the notes with some simple geometric shapes, geometric volumes, that's what I'm looking for, of a plate, square plate, circular plate, sphere, rod, and cylinder, and we'll be using those. We're not going to integrate mass moment of inertia in this course. There is also parallel axis theorem. For mass moment of inertia, and it is IZ is equal to centroidal IZ prime plus MD squared, where IZ prime equals the centroidal mass moment of inertia M is equal to mass, and in this class that is either a kilogram or a gram or slugs. We do not do pounds mass in this class. Okay, it's either slugs or kilograms. And then D, which is going to be the perpendicular distance between, in this case, the Z and Z prime axes. All right, now you're looking at this going, if we have an r squared, which is a length, times a mass, then your units are going to be funny, and you are correct. Our units are going to be in mass times length squared, like meters per kilogram per meter squared, or slugs per foot squared. Okay. First example, I'm going to give you a plate. This is a square plate. That is unfortunately void of cookies. It is made of one material, so its geometric center happens to also be its mass center. So there is G for mass center. I'm also going to put a place over here called O. The height of my plate here is 2 meters. The width of my plate is 3 meters. And the depth of my plate doesn't matter in this case. All right, I wish to find the mass moment of inertia and the radius of gyration which which I didn't mention either, but the radius of gyration, it's still k, and it's equal to the mass moment of inertia divided by the mass, right, and take the square root of that, through points G and O. Okay, now this is going to come into play if you're wondering, why are we talking about this? For dynamics. Dynamics, we've got rotating things, moving things, so the mass moment of inertia is used a lot there. We use it a tiny bit in fluids, but you're definitely going to see it again in dynamics. Solution. Okay, on our properties of solids page, we see that the mass moment of inertia about the mass center G for a plate is m divided by 12 times a squared plus b squared. So for us, that's going to be, lack of information because I didn't give you the mass of the plate, mass is equal to 60 kilograms. Isn't that fun when I don't give you all the information? No, it's not, but there it is. We're good. 60 kilograms divided by 12 times a squared, which is 3 meters squared, plus b squared, 2 meters squared. And that gives us a mass moment of inertia about the mass center of 65 kilogram meters squared. Okay, now I'm just going to use parallel axis theorem to move it. So IZ, which in this case, okay, IO, so that's about the upper left-hand corner there, which is not the center, is equal to the center, IG, plus mass times distance squared. So this is going to equal to 65 kilogram meters squared plus my mass, 60 kilograms, times the distance I want to travel. Okay, this is going to be a straight on distance here, D. So I don't know about you, but this looks to me like a right triangle with a width of half of 3 meters, 1.5 meters, and a height of 1 meter. Okay, so that means that my distance D is going to be the square root of 1 squared plus 1.5 squared meters. And I need D squared. So there's that square there. And doing some math, I find that the mass moment of inertia about an axis through point O is equal to 260 kilogram meters squared. Now that I have those, I can find the kg, which is going to be IG, 65 kilogram meters squared, divided by the mass, 60 kilograms. And you see here that it all works out nicely, that we still end up with a length, 1.04 meters. And KO is going to be 260 kilogram meters squared divided by 60 kilograms. And this is equal to 2.08 meters.